Okay, so I might won't able to open the screen, but still it is visible properly for everyone, right? Hello, you can just okay, okay, got it. So let's cover the basic probability first. Okay, here is tabular data I have created. The similar data you are going to see in Arrowfit also. Okay, here you can see that in arrowfit whatever probability we are looking is in the tabular format. Okay, so let's understand on the basis of this particular tabular data, and after that the same thing we are going to apply in the like format of coding. Okay, so here is something that the HBO cable network took survey of 500 subscriber to determine people's favorite show. Okay, here you can see the three serials are there like Game of Thrones, Westworld, and the rest of the others, right? And how many males are interested in that particular game or shows, and how many females are interested in this particular show. Okay, so what we have done, we have divided the number of this 80 divided by 500. Okay, so in that way we are able to get the probability, and this 500 is not divided by just inside the tabular. You can see the total also. Okay, so how many total people who are interested in Game of Thrones. Okay, so 120 plus 80 is 200, here you can see. And in Westworld that 125 people are interested, and for other 175 people are interested. Okay, and this is the marginal sum of this particular game, this particular shows. Okay, so rather than other in other side, you can see 230 and 370 here, irrespective of which show they are interested in. I wanted to know that how many males are watching our HBO cable network, and how many female are watching our HBO network. Okay, you can see that 230 plus 270, and that is total 500. For this side also it is 500, for this side also it is 500. Okay, so now what we are going to do, we are going to divide it with the 500. Okay, so 80 divided by 500 is something 1.6, and this is like for every single data we are going to divide it with 500. Okay, so 500 divided by 500 is equal to 1. That's why you are able to see 1 here. Rest everything like marginal also and inside the tabular also, it is divided by 500. Okay, so this the whatever data that you are able to see inside this particular table. Okay, 16, 24 to 0.5, 0.05, 0.1 or 0.25, these all are the joint probability. Okay, how to rate this joint probability? Okay, so you can see it is a joint probability, probability of female and GOT, that is Game of Thrones. Okay, so how many people, how many males are interested in Game of Thrones? Okay, so here two things you have to consider, female and the Games of Thrones. Okay, so joint probability is something when two conditions are applied. Okay, joint probability. So 0.24 is the probability of something where females are interested in the Game of Thrones. Okay, and here females are interested in the Westworld, their probability is 0.05, and females are interested in the others, that is 0.2. Okay, and in a similar way, when you are going to say that what is the probability that males are watching the Game of Thrones? Okay, so here the two conditions I have to fulfill, male and Game of Thrones. Okay, so 0.16 is the probability that we can tell that 0.16 males are interested or watching the Game of Thrones. So this is called the joint probability, whatever you are able to see in this tabular format, which is not in total. Okay, total is something that is marginal, I will show you that, and you can see that probability of female and Game of Thrones is equal to 0.24, and this is called the joint probability. Okay, and the next thing, it is the same thing, I am just mentioning that which area is covered is known as joint probability. Okay, so the inside area that is covered is the joint probability. Next thing that we are going to cover is the marginal probability. Okay, so it is the same data. Whatever you are able to see here, it is the same data. Only the thing is that what is the probability that anyone is interested in Game of Thrones, rather than it is male or female, it doesn't matter how many persons are there who are interested in Game of Thrones. Okay, so their probability is 0.4, and this is called the marginal probability, and this is also called the marginal probability. Only question will change in a way that how many males are interested to watch the HBO network. Okay, rather than it is Game of Thrones, Westworld or other, I am just interested in how many males are interested in our serials or our shows, and how many females are interested in our shows. Okay, only the question will be switched on the basis of if they are male or female, and if they are anyone either male or female, how many people are interested in Game of Thrones. Okay, so this outer line probability is known as the marginal probability. Here you can see these all are the marginal probability. Understood everyone till here? You can unmute yourself and let me know that you are understanding. Getting it? This is also the outer side is the like marginal probability of male and female. Okay, so the next topic is the conditional probability. This is something that you have to understand this one is a bit complicated one. Okay, so here is something you can see, it is the same thing, the male and female. But here the question is, Noni is got HBO subscription, and what is the chances that her favorite show will be the Game of Thrones? Okay, here you can consider Noni as a female. Okay, Noni as a female. So here you can see that in next topic, that how we are going to calculate the conditional probability. Okay, so probability of being a female who are watching Game of Thrones is 0.24. Okay, so 0.24, but here my condition is like if she is female. Okay, and what is the probability? Like you can see that she is female and this is the Game of Thrones. That means P A union B. So this is the joint probability data you are able to see. Okay, and how many females, how many total females are there? Okay, because we are interested in finding, given that it is a female. Okay, given that it is a female, you can see here Noni is just got HBO subscription. What is the chances of her favorite show is Game of Thrones. So Game of Thrones is the condition on which we have to check, but the given thing is the female thing. Okay, how many total females are there who are watching our TV show? So their probability is something 0.54. Okay, now I wanted to know how many females are interested in Game of Thrones only and only. Okay, in that condition, we have to divide the probability of female who are interested in Game of Thrones divided by how many total females are present. Okay, because these are like Westworld is also watched by few females, other is also watched by few females, right? So here is condition. The condition is something if they are female. Okay, who that is 0.54 in total. 0.54 are the total female. How many are interested in Game of Thrones? So in this way we are going to divide 0.24 divided by the total female who are present. Okay, so then in that case we will get the 0.444. So this is the probability if they are female, which is already given. We don't need to find the probability of like how many females are there. It is already calculated as the like marginal probability. On the top of that, if I wanted to know how many females are interested in Game of Thrones, we will divide the A union B. Okay, this A union B is something Game of Thrones and female, which is 0.24 divided by the total female. Are you getting this concept? Anyone have any question here? So the same thing is given to you in an opposite manner. Okay, given that a person like is watching Games of Thrones, then what is the probability that they are female? Okay, so here is the something that what is the probability that they are male? Okay, so either thing you can do. If they are male, you can divide it by 0.25, and if they are female, then you have to divide it with the I think yeah, male female, yeah, female. If you have to take the female, you have to take 0.5. So here is something you have to check the given thing first. Okay, so here given thing is the female thing. Okay, that we already know that female is there for the show, and we wanted to know the a specific game who like is a specific interest, like a show interest of a female. Here you can see that given that the subscriber favorite show is the Westworld, so it is already given. So you can see the total person who are interested in Westworld is the 0.25. Then what is the probability that they are male? Okay, so here you can see the male and the Westworld probability is 0.2. So you can take 0.2, and the total person who are interested in Westworld is 0.25. So you can divide it and you will get the 0.08. 0 like 8. But here if they are female, you are going to take this one. Okay, you are going to take this one as the first data, and 0.25 is the second data. Okay, so whatever is given, their total probability you have to take as a denominator, and whatever thing you have to find out. Okay, so if you wanted to find out the probability of male, probability of female, that you have to take the joint probability. Okay, so this is the formula of the conditional probability, and you can get it anywhere, even though I have explained you in a best way that I can do. So total thing you have to take at the bottom, and the joint probability you have to take as a numerator. Everybody understood this concept of marginal probability, joint probability, and conditional probability? Yeah, yeah, sure. Okay, so here you have to consider few things. Okay, so here you can see that P GOT slash female. Okay, so this slash or like a straight line female is there. Okay, so whatever is written later, okay, whatever is written later, here you can see that female is written later. Here you can see Westworld is written later. So you have to concentrate on this particular data. Whatever is written later, that is already given. Okay, if that is already given, in that case you have to take the probability of this female. Okay, total probability. Okay, you can see that total probability is taken as a denominator, and it is written later. Okay, and after that whatever probability you have to find out. Okay, her favorite show is Game of Thrones. So this one, the GOT, that you have to take as a joint probability of like GOT and female. So you can see that this is the joint probability. Whatever is inside the box. Okay, here you can see, okay, here you can see inside the box is the joint probability. Okay, this joint probability in the sense female union, like it's union or intersection. Yeah, intersection. Okay, intersection in the sense it is the joint probability. You can see here the joint probability. Joint probability is 0.24, 0.5 for every single thing. This you understood, right? Alright, Mayu, this is the confirmed thing that you understood. Okay, so let's come to the conditional probability. So here you have to read this thing at the first point. Okay, probability of Game of Thrones given that they are female. Okay, so and whatever is given, you have to take the marginal probability of that particular data, which is probability of B, that is probability of female, and whatever probability that you have to find out, like GOT, you have to take GOT intersection female. Okay, so this is the joint probability at the top you have to take. So why this you have to understand this logically. Okay, so if we already know that they are female, then we don't need to take it for like total population, right? So we already know that female probability of Game of Thrones is 0.24, like female probability of watching Westworld is 0.05, and the other is something this is. Okay, now we wanted to find out on the basis of condition. So condition is something we already know that she is a female. Okay, we already know she is a female, we don't have any confusion. Okay, so we already know that she is female. We wanted to know that what is the probability of Game of Thrones given that she is female. Given that she is female, so given thing we have to take as a denominator, and in the numerator you have to take the joint probability of GOT on female, and you will get the answer. Okay, so now you understood this thing, Mayur? Okay, okay. So this is the same thing happening. See, this is the column wise. We are like getting these things. So we are using both thing, column wise and row wise. Okay, here you can see the marginal probability that I am checking is for the female. Here the marginal probability we are checking for the west world. So now the question is reversed. Now the question is reversed, and we wanted to know, given that the show that is watching is the west world, I wanted to know how many males are watching the west world. Okay, so we already know that 0.25 of the population are watching the west world. Okay, now in this 0.25% or like of the people, how many are male? So you can see that like a marginal probability of west world I have taken here. Okay, so what is the probability that a person is watching west world? So you can see that this probability is present here. Now, in the second case, I wanted to know that how many males are there who are watching the west world. Okay, so their probability is 0.2. So we are able to see that we can see that A intersection B is there, and this is also called as joint probability. Okay, P like in bracket A union B is also called as joint probability. Okay, and this is divided by the marginal probability. Only after that we will get the conditional probability. Understood this thing, everyone? Any confusion in this particular case? Okay, this is a bit formula that you have to take care or understand. It is very easy, not that much difficult. Okay, so now we are coming to our project. Okay, we are coming to our project. That is, now I wanted to find out the conditional probability. Okay, you can see that we have created this thing, and now we are going to see how this conditional probabilities and all are converted into the coding. Okay, give me a moment. Okay, just wanted to put this thing so it won't be any confusion. Okay, now I am just copying pasting the code, and after that I'll make sure that you guys understand every single thing. Okay, so there are like different like blocks in this particular code. Okay, so every single block is used for creating the every single graph that is created here. Okay, you can see. Let me run. Okay, I think it's already connected, but still let me warning this not to be authorized by. Yeah, I am the only one who took the. So let's try to run this, and wait a sec. I just need to check that this is already imported. So we lost our runtime actually. Okay. Okay, till here if it is run, then we are able to run this also. Okay, you can see the lots of thing here. So first we'll understand the visual part, then we'll go on the details of the coding. Okay, here you can see the count distribution of gender and product also. Okay, so here it is a product also, count distribution of gender and product. Okay, so the first table that I have showed you in the like Game of Thrones and that particular example, the same thing you can see that I have created here also. So if a particular product is there like KP281, how many males are there, how many females are there? For like KP481, how many males are there, how many females are there? And for KP 781, how many male and females are there? So you can see this is a count table. Okay, now we wanted to divide this we wanted to find the joint probability and the marginal probability of gender and the product, and you can see the total number is 180. Okay, we already defined that. So if I wanted to show the margin here also, okay, let me just do the margin tool in the first graph also, then you will see the total also. Might be. Yeah, I think there is a bit space issue is there. Okay, so space issue, how can I solve? Okay, so it's a difficult thing to like change the code right now, because I can to take the space I can draw the first two thing in a first and later after, but it's fine. Okay, we are going to use like this only. Okay, 20 is to 5. We can't expand from this. Okay, so it's fine. So you know that how many total, you can see that here 76 is there. If we got space, we are able to see the total also. Here you can see the total is 80. Here you can see the total is 60. Here you can see the total is 40. Here 180 should be there, and here whatever is the total, it should be there. Okay, so there is some space issue. That's why we aren't able to see this. But you can see few data are coming. Few are like with the space issue, they are not coming. Okay. So here you can see, so whatever the three letter data is not coming, two digit data is only coming. So 40, 30 and 33 will be something more than 100, and this is also something more than 100. That's why it is not visible actually. But anyway, we are going to divide it with the 180. Okay, so if you divide it with the 180, like 40 divided by 180, if you wanted to do, let's see this in a code. Okay, print 40 divided by 180. Okay, so I'll show you like few divides and all, so you can understand. So you can see 0.222. So you can see 0.2 is written. So if the same thing is happening here and here, you can see 7 is very small in comparison to 180. That's why we are getting 0.039 as a probability. Okay, and now here 76. If you divide the 76 from the 180, you can see this is the 76 is the margin. Okay, the margin of total products of female, like how many total females are there who are purchasing our any product. Okay, you can see it's like 4.2. You can see 4.2 is mentioned here. Okay, so everything is divided by 180, and whatever you are able to see in this particular section. Okay, first three and next three boxes, these are the joint probability, and the later these three things and these two things are the marginal probability. Okay, so marginal probability, how we are going to read? So we are going to read the marginal probability is in a way that how many females are there who are interested in our product, any product. Okay, and how many males are there who are interested in our product. Okay, so this is the 0.58, and this marginal probability we have to read in a way that like how many people are there who are interested in KP281, so that is 0.44. How many people are there who are interested in KP481, and how many people are there who are interested in KP781. So these three probability you are able to see here. Okay, now what we have, okay, I don't know why this happened. Is the pop-ups are visible to you guys? No, right? Okay, so let's ignore that. So next thing that we are going to cover is the conditional probability of a product given that in the gender. Okay, so gender is given, male and female is given, and we need to find out the probability of each particular product if the gender is already given. Okay, so we understand here that if something is already given, okay, already given, so in that case we have to take their total probability. Okay, so let's understand this thing. So here you can see that all is represented here. Let us see. Yeah, let me resolve. So margin is something. So here you can see that this is the 0.42 is something is the total females are there, and 0.58 is the total males are there. Okay, so if I wanted to know that if given that if it is a female, what is the probability that he will or she will take the KP281? Okay, so in that case we have to divide this 0.22 with the 0.42, right? Because you can see that KP281 and female joint probability is 0.22. So we have to take joint probability as a numerator, that is 0.22. And what is the total probability that she is a female? It is 0.4. Okay, 0.42. So if you run this, you are able to see that 0.523, that is 0.53 is the our total probability. So this is the conditional probability. So if given that she is a female, okay, given that she is a female, what is the probability that they will purchase 281, they will purchase 481, or they will purchase KP 781? Okay, and given that they are female, what is the probability? So this particular line, it should not be here, 0.44. Yeah, this is the all probability. Okay, all probability of male and female. It is same. Okay, it is same. So we have to divide it. No, it is not divided by 0.44. Okay, so this thing we need to off this margin. Wait a sec. Margin, it should be removed from here, because in this particular thing we don't need the margin actually. Okay, in conditional probability we don't need the margin. Okay, now you can see the margin is removed. Now there is no margin, and we are able to see the proper only conditional probability of any product given that they are male or female. Okay, now we have to do the conditional probability in another way. So here the product is given. Okay, here the product is given. Now I wanted to know what is the probability of being a male or being a female. So we have to like select this particular, we have to see this particular graph. Okay, so now what is the thing? So given that the product is KP281, okay, so KP281 total probability is 0.44. What is the probability that they are male? So in this case we are going to divide 0.22 by 0.44. Okay, you can see the total probability of KP281 is 0.44. Okay, and what total probability that male is there, that is 0.22. So whenever we divide it, we are able to see 0.5 is the conditional probability, and here you can see 0.5 is the conditional probability. It's given. Okay, so if I wanted to know if a female, if a product is KP70 781, what is the probability that she's a female? Okay, so KP781 total margin probability is 0.22. So we will take 0.22 in a numerator. And what is the probability that she is a female? So we will take the joint probability of female and KP781. That is 0.039. Okay, 039. So in this case, we are able to see it's just 17%. Okay, 17%. So in this case, you will understand the how many conditional probability. So given that the product is there, how many person are male and female for this particular category. Okay, this particular category. Let me know that you guys have any confusion in understanding the number and charts that is present here. Anyone have any confusion? Understood properly, everyone? Ritika, Sheikh Mohammed, Shanika, Sonal, Tejas. This is might be a bit tricky, but if you write it down in copy and pen, you will able to understand. Yes, Tejas, you wanted to ask something? Okay. Okay, fine, fine, fine. So now the second thing that we are going to check is the code. Okay, now how we are drawing this thing? So you can see that this is a heat map. Okay, you can see the probability where it is the highest, it is the dark color, and where probability is the lowest is the light color, and which is medium is the in between them. Okay, so this is a heat map where number is also populating. So you can draw a heat map without populating the number also. You can draw a heat map with populating the number also. Okay, so I am drawing the heat map with populating the number, and let's see how we are going to do this. Okay, so first thing that is I have to create is the pd dot cross tab. Okay, we have to create this cross tab first because we don't have this cross tab. We have a table. Okay, but we have to create a table in which male count and female count is divided by the KP281. So you can see that contingency table. This is called contingency table. You can do draw that particular type of table by using the pd dot cross tab. Okay, if you do pd dot cross tab and you have to pass two data. Okay, I have passed two data, df gender and df products. Okay, margin I am putting true. Why? Because if you don't put the margin, you won't able to see the total. Okay, so previously I haven't mentioned the margin and we are unable to see that properly also. So that's why we are removing the margin currently, and normalization is also by default it is false, so we don't need to put it. So let's understand first to just create a cross tab. Okay, so this is the simple code for creating a cross tab, pd dot cross tab, and you just have to pass the two data inside it and it will create a cross tab. Cross tab is something counting and divided it accordingly to create this type of table. Understood? The second thing is plt dot fig size. This is one time thing. Okay, plt dot fig size. You are defining the size of the white space that we are going to use right now. Okay, so this fig size is 20 is to 5. So in by 20 it is taken completely and this height is 5. Okay, this you already know. And we are dividing this space into one row and four column. Okay, one row and four column I am dividing it, and now I am using the first one as below. Okay, so you are going to draw write a code that is sns dot heat map. Okay, sns dot heat map, and inside that heat map you are passing this table. Okay, this the table you have created in the first section. That table you are passing only here. Okay, and not true is something. This and not true is like show the number on the top of the like heat map. If you don't put this anode, so let's try to like remove this anode and we will check that what we won't able to get. Okay, so in first graph only I am removing the anode. Okay, so if I remove the anode, we won't able to see this data like 80, 40, 31. Okay, we'll do that later. And let's run this and see this right now only. Okay, you can see that only heat map is created. You have to like see the colors and all and you can analyze on that basis. But if you wanted to see the data inside that, okay, data inside that, then you have to do and not is equal to true. Okay, so this is the more convenient way you are able to see the like more detailed data. So this is the code of first create the first subplot. Okay, you can close it and put it here. So this is the first subplot you are creating. This is the second one, this is the third one, this is the fourth one. Okay, so there are few attributes that I am adding in the pd.cross tab. Okay, and we are using the same data to create the heat map. Okay, so in pd.cross tab only you can see that I am putting that df.index and df.product. Okay, so now here I am specifying the index and I am specifying the column. Okay, so here you can see that I haven't specified anything which is index and which is column. Index is something that I want this thing in a row and I want this thing in a column. Okay, drop any true in the sense that if any missing values are there, then it will be dropped. So there is no not available and missing value. So this is if you put this also, that is also fine. If you don't put this also, that is also fine. Okay, so in this second graph we are going to create margin is equal to true. Why? Because we wanted to see the marginal probability also. Okay, if we don't on the margin, if you don't on the margin, this margin we won't able to see, right? All and all, like all of male female and all of all of male female and all of product. Okay, so this particular margin is going to show that, and normalize is equal to true in the sense we are going to see the probability. Here you can see I am not using the normalize is equal to true. Generally normalize is false. Okay, in default normalize is false. You can go and check the pd.cross tab. Okay, pd dot cross tab documentation. Okay, documentation. Here you can see there are multiple things that we have to we can do, and what is the default things are there. You can see normalize is false, that is by default it is true. Drop n is true by default. If you want to mention it, you can mention, otherwise in default this is true. Margin name like all, and you have to put the margin as true if you wanted to see the margin. If you don't want to see the margin, don't need to put margin name also, like it is by default false. Okay, so here you can see the different things that you can pass. Okay, here you can see that can pass the index, I can pass the column. If you didn't specify that which is index and which is column, it will automatically take the index and column according to their whatever they want. Okay, since I have passed the first data here, yeah, first data here as gender and product, so that's why it taken as gender as a margin and product as a column. Okay, so this is the first contingency table I have created, and I have used this in the first graph. Okay, now I am creating the second contingency table. Okay, second contingency table, I have specified the index and column, because on the basis of this index and column only, I am able to normalize on the basis of index. I am able to normalize on the basis of columns. Okay, normalize in the sense, given that the if index is already given. Okay, index is something, is gender is already given. Now what is the probability of a particular different products? Okay, so here you can see that in third graph. Okay, in third graph we have the probability, that conditional probability of product given that they are gender. Okay, so you have to specify the code that on what basis you wanted to do the conditional probability, which particular data is already given, gender is already given or the product is already given. Okay, so that thing you have to do in the normalization part. If you do normalization is equal to true, it will create you the joint and the marginal probability. But if you wanted to find the conditional probability, you have to specify the index, that is only if you have to specify either it is index or either it is column, that is already given. So here you can see in index I have mentioned the gender. Okay, I have mentioned the gender. So in index, if we normalize, I pass the index, that means that I am telling this particular graph, given that it is a gender, okay, given that it is a female, what is the probability that they will purchase 281? If they are female, what is the probability they purchase 481? Okay, so this is the meaning of this particular graph. And the fourth thing, like normalization is equal to column. So in column you can see that I have product pass the product. Okay, so given that if it is a KP281, what is the probability that she is a female or he is a male? Okay, so here by this particular code you can pass the condition of the probability that you wanted to see, and whatever you wanted to make as a given you can pass in the normalize. Okay, so drop true, you can remove it because by default it is true. We don't need it. Okay, margin here, I want the margin. Okay, you can see that I have removed the margin here. You can keep the margin, but in conditional probability there is no use of margin. Okay, in marginal probability only we need the margin, otherwise we don't need it. Okay, rest everything you already know. I am passing the table of the contingency table to create the heat map. I am putting the N naught is equal to true, and that C map is the color thing. Okay, so YLGN blue is the color. You can see here for color what we can do. I think for color it is not mentioned something. Okay, C map, C map should be there. Okay, CMAP is not there, but you can put the color. If you don't put the your own color, it will by default take some color. Okay, but yeah, we can do that. So now let's run this particular column, like particular code. and you are able to see that count distribution of gender on product. We are able to see like how many total are there. Now this is the joint probability and marginal probability. We are able to see why, because we put the normalize as true and margin as true. Okay, we are able to conditional probability on the basis of given gender. Gender I have passed in index, that why I have passed index in the normalize. Okay, and conditional probability of gender given that it is a product. Okay, so I have do the normalization on column, and in columns you can see that I have passed the product. Okay, in this way you can create the every single graph, and the rest of thing are the same that you have already learned. You can put the title, you can put the subplot in the sense in one row and fourth column. I wanted to use the fourth column to draw this graph. Okay, in 1 by 4 I wanted to use the third space, in 1 by 4 I wanted to use the second space, and here I wanted to use the first space. Okay, so rest every code is like repeating, and in the end you are able to see this particular heat map. Okay, are you guys able to understood this thing? Any questions here? Are you able to understand every single code properly? Okay, great, great. Thank you so much. So in the same way, you can do for the here you can see that I have mentioned few things as a remark also. Probability that a customer if wanted to buy KP 281 and she is female is 22. So whatever I have taught you is the same thing I have mentioned here. Okay, so in a written form. Okay, whatever you are, if you are you like analyzing something very rare, you can see that this 7 is very less. So the probability of being a female and purchasing 781 is very less, but the probability of female purchasing 281 is very high since it's a very dark. Okay, and you can see that here is also 781, like male is like very dark. So if a person is purchasing 781, then there is a 82% probability that he's a female, like he's a male, and like 0.17% probability that she's a female. So these are the readings only I have written here, and you can just go through this. I will share you the every single code. Okay, so since it is a project, you also have to like invest put effort in understanding and creating few things that is already created. Okay, you can do the experiment, you can remove something and see that what is the changes I'm going to see, and now replace it, then you are able to see something that is good. Okay, so this is the thing you are going to see on the basis of marital status and the product distribution. Okay, so on the basis of marital status, if a person is single or partner, what is the probability of the things? Okay, so here you can see that if a product is already given, there is a high probability that they are married. Okay, so every single thing is like dark here. And if a person is a partner or single, in either way there is a high probability that they will purchase the 281. Okay, so this is the like importance of conditional probability that you will get. Understood everyone? So in this way only I am completing this project. I will share you both the links, go through every single link, and there are lots of like you can see the comments and all that you are able to see, and there are lots of things that you can understand, the recommendation, the insights generation, everything is mentioned here. Okay, so there is only one small code that I wanted to show you everyone. What is df.curr correlation table? If you wanted to create, you can create this correlation table. Okay, so this correlation table like why it is not coming, float kp281 string to float. There is some error. kp281 is yeah, it is a string. Okay, it is a string. Okay, there is some warning here. Let me check. Yeah, can numeric to silence. Okay, there are few more code that I have to. So df.curr work only on like numerical format. Okay, so previously it is removing the string automatically. Now we have to remove the like string like with our own. Okay, with our own. So mm, 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 mm. How many strings are there? Product, gender, and marital status. Three are there, right? Uh, Wait a sec. df1 is equal to df dot drop product comma marital. I need to check the exact column name, marital status, and product, and which one? Gender. Let's try to run this. Call from delivery identified by. Okay, method object is not susceptible. There might be some. Call from delivery identified by. There might be some syntax error. Let me check. Okay, check it. Incoming call from delivery identified by Truecaller. We'll try this since we have time. We can try this. Okay, there is no worries. You can also see that if some error happens, then you can. How can you like check this? Check the syntax to drop multiple column path. Okay, axis 1 I have to mention. Okay, axis 1. Let's see if it works or not. Okay, it works. Now df1.corr4. Let's try to run this if it works now or not. Okay, now it works. Okay, so previously see every time codes are being updated. Okay, so when I created this, it is not required to remove the like string related thing, but you can see the like future warning it is given. The default value of numeric only in data print is different. In the future version it will be default false, select only valid columns, and then it will be like okay. Okay, so here at this time it was on the process of upgradation. Now it is upgraded, so that's why I am won't able to write the CORR directly with or including int or including the string. So you can see that I have dropped the column on like by axis 1. I have dropped the column of every single column that is in the string, and the remaining thing I stored in df1, and after that I just put it CORR, and we are able to see the correlation table. Okay, so what does this correlation table actually means? Okay, this correlation table actually means if someone is correlated more than 0.5 or 6, so 0.6 is more preferable. Okay, here you can see that 0. Can you give me a moment? I am getting called like again and again. Give me 2-3 minutes. I'll back. Okay. हेलो हेलो हाँ भैया बोलिए ऑर्डर किया था मैंने हाँ 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 सर बोलिए मेरे लोकेशन पे आप पहुंच गए हैं ऑलरेडी। अच्छा हाँ हाँ ठीक है, मेरा आप अपना नंबर दीजिए और मैं लिख लेती हूँ आपका नंबर। हाँ बोलिए, फिर से बोलिएगा एक बारी। 78 4929। अच्छा 2929 ठीक है। 782929 उसके बाद 4987। एक बार चेक कर लीजिएगा, 782929 4987। ठीक है, मैं आपको इस लोकेशन इस नंबर पे आपको लोकेशन भेज रही हूँ, ठीक है? कितने देर में आ जाएंगे? ठीक है, मैं आपको अभी भेज रही हूँ लोकेशन, ठीक है? हाँ अन्ना, मैंने आपको लोकेशन भेज दिया है इस नंबर पे, लेकिन वो सेंड नहीं हो रहा है, टिक नहीं हुआ है। मतलब सेंड हुआ है, आपका इंटरनेट ऑन है ना? आया नहीं है। मैं आपको लोकेशन ना आपके एसएमएस पे भी भेज देती हूँ, ठीक है? ठीक, मैं आपको आपको टेक्स्ट मैसेज में भेज देती हूँ, एसएमएस में। ठीक है, ठीक है। Yeah, hello everyone. Am I audible to you? Okay. So this is a correlation table. If something is more than 0.5, we can see that it is highly correlated. Okay. Education is highly correlated to income. Okay. And fitness, you can see fitness is highly correlated to usage. But if wherever you will get something more than 0.5, it is highly correlated, and it is like 0.1 or 0.2, then you can see that it's not that much correlated. Education is nothing related to age, and you can see 1 1 1 1 1 year, because if miles will be correlated by miles, then it will be 1 because they are the same data. Okay, so we have to ignore this one, and we have to focus on rest of the things that which are highly correlated. Income and education is also highly correlated. You can see that whatever is present in the upside is present in downside also. So you can see that 0.7 usage and miles is also highly correlated. Fitness and miles is also highly correlated. Okay, so in this way you can just find out that which are the columns are correlated to each other. Okay, that's all. So in this way you can analyze the data in a more appropriate way, find the answers whatever mentioned here. Okay, and you can complete this project. If you are getting any difficulty and all, let me know. I will make sure that you will understand. Anytime you can use the chat gpt and all to understand the or correct your syntax if you are not getting it. Anyway, I have corrected all the syntax that is like error or in warning. That's why I will share the both of the data, and at this stage your python project is completed. Okay, everyone understood? Now we are going to see the SQL project. Let me know that you guys are able to understand our project, Python project or not. Okay. So, I already have the, I already shared you the question, right? This business case study of SQL, right? Still, I think few people are won't able to like complete it. So let me just reducing the tabs to, and we'll focus on the SQL project. Okay, so here one thing is there. I have already created the SQL project. You can see SQL project I have created. I will make sure that you guys will understand this, and if you wanted to run it or like take it understand every single thing, you can just open your BigQuery, and you can just copy paste. If you want to do copy paste also, that will also work. Okay, because the every single thing and the data set I have given is the same to same, nothing to worry. Okay, but still if you I am going one by one on every single questions that we are getting. Okay, so first of all we'll understand the schema. Okay, schema is something how this particular IDs or particular databases are related to each other. Okay, so you can see the order payment data set is related to order data set by the order ID. This order data set is related to the order reviews by order ID. Okay, and the order items data set is related to this order data set by order ID. This product data set is related to order set by the product ID. Okay, so which is the common ID present in these two particular tabs here is present here. Okay, product ID. These two databases are related to the seller ID. These two are related by the zip ID. This two is also related by the zip ID. This two is related by the customer ID. Okay, so according to our problem statement, we are going to deep dive into the questions that we have to answer. Okay, here you can see the data type of all the columns and the customer table. Okay, data type. So we are going to see, go upward. Okay, so here you can see sellers. Okay, so data type is something that you have to do the exploratory thing. I have already told you. Get the time range between. Still, I have written few examples. Wait a sec.